Hello everyone, my name is Apurva Go. Today I am going to solve a problem related to proofs related to R bar. Here the question is, if R bar and R have their usual meaning and A bar, B bar are constant vectors, then prove that these three terms. Now here we solve. We know that R bar is equal to X I bar plus Y J bar plus Z K bar. Therefore, R square is equal to X square plus Y square plus Z square. Here we know that the derivative of R square is R square dou R upon dou X into dou is equal to dou X. Then here 2 gets cancelled. R comes here. Therefore, it becomes dou R upon dou X is equal to x upon r. Similarly, dou r upon dou y is equal to y upon r, and dou r upon dou z is equal to z upon r. Here we know that a bar is equal to a1 I plus a2 j bar plus a3 k bar. Now we will solve the first proof is a bar dot dou into r bar is equal to x. Here LHS is equal to a bar dot dou into r bar. Here we know that the a bar is equal to a1 I bar plus a2 j bar plus a3 k bar, and dot product of dou means I bar dou x plus plus j bar dou upon dou y plus k bar dou upon dou z. And we know that r bar is equal to xi bar plus yj bar plus zk bar. Here the dot product of a and dou is becomes a1 dou upon dou x plus a2 dou upon dou x dou y plus a3 dou upon dou z into xi bar plus yj bar plus zk bar. Then dot product of this becomes a1 I bar plus a2 j bar plus a3 k bar. Then we know that a bar is equal to a1 I bar plus a2 j bar plus a3 k bar is equal to a bar. Therefore is equal to RHS. Therefore the second proof is dou a bar. Here LHS of second proof is dou into a bar dot r bar. It's equal to, we know that dou is equal to x bar dou upon dou x plus j bar dou upon dou y plus k bar dou upon dou z into bracket. We know that a bar is equal to a1 I bar plus a2 j bar plus a3 k bar into dot product r bar is xi bar plus yj bar plus zk bar. Dot product of a bar and r bar becomes, we write the dou as it is, and dot product of a bar and r bar becomes a1 x plus a2 y plus a3 z. Then dot product of dou into this, it becomes a1 I bar plus a2 j bar plus a3 k bar. We know that a bar is equal to a1 I bar plus a2 j bar plus a3 k bar. Here RHS. Then the third proof is dou Rn is equal to n of n into r n raised to minus 2 into r bar. Here LHS is dou into r raised to n. We know that dou is equal to I bar Salji. We know that r raised to n bar is equal to x square plus y square plus z square raised to n by 2. Here dot product of this is becomes I bar n by 2 x square plus y square plus z square raised to n by 2 minus 1 into 2x plus j bar n by 2 x square plus y square plus z square raised to n by 2 minus 1 into 2y plus k bar is equal to k bar into x square plus y square plus z square raised to n by 2 minus 1 into 2z. Here 2 get cancelled. here n by 2. Then it's there are common terms in it. It is n x square plus y square plus z square. N by 2 minus 1, it is common. 2xi bar plus yj bar plus k bar. Here we know that x square xi bar plus yj bar plus zk bar is r bar. Then n x raised to n x square plus y square plus z square. We know that n by 2 minus 1 is equal to n minus 2 upon 2. Then we know that r bar into r bar. Now we know that r square is equal to x square plus y square plus z square. Then we write r square here. R square raised to n by 2 minus 2. Here 2 gets cancelled. Therefore, it becomes n r raised to n minus 2 into r bar is equal to RHS. Here, hence proved. We completed all proofs.